So these are your guided notes to midpoint. We're going to walk through them, and this will be the key. Alright, so what I'd like you to do is fill this out while we're filling this out, and come to me with your questions that you may have. I'm going to fill this out to the best of my ability, and help you out on your way. So we've already talked about several of these things in class. So the midpoint of a line segment is the point that divides a segment into segments of length, 2 equal segments of length. Okay, 2 equal segments of length. Okay, so it's basically the point that's in the middle of the line segment. Alright, so if I have this as a line segment, all we got to do is we count how long it is, divide it in half, and that'll get it to us, right? 1, 2, 3, 4, 5, 6, 7, 8. This is a line segment of 8. So we know that halfway between it should be 4, right? It's 1, 2, 3, 4. So right here should be the middle. So that would mean the point, or the ordered pair that describes that point, would be 1, 2, 1. So the midpoint would be at 2, 1. Right? So how do we find it? Well, we just counted how long it was and divided it by 2. Now some of you may have done this differently. Like there are some, for instance, who would probably add -2 and add 6, because that's the beginning point and the end point. And if you add those 2 points, you would get such. Oh, let me zoom in so you can see a little better. Alright, so if you added -2 and 6, you would get 6 plus -2. So you're adding a negative, so they're different signs, so you would subtract. And you get 4. You get 4 way over here. If you added those and divided it in half, you would get 2, which is exactly where we want it to be. So that's another trick. And let's keep going on to this next problem here. This next problem, this line is diagonal. Now I don't know how long that piece is, or that piece, because it goes partially through one of the boxes. So I don't know what the exact length is, and I can't just count 1, 2, 3 like I did over here, because the length across a box is not the same as the length along its side. So we have to use a different method, and we're going to use the method I showed you in that other video, where I'm going to use the average of these 2 points. So instead of counting along this side, I'm going to count along these 2 sides. Okay, I'm going to count along this side and find the middle, and I'm going to count along this side and find the middle. And let's find that out. So I got 1, 2, 3. So this length right here is 3. Halfway between 3 is 1.5. Alright, so this is parallel with the x-axis, so we're going to say that's the x-axis. So 1.5 or 3/2, that's the same thing. And then I'm going to count along this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10. Halfway up would be 5. 1, 2, 3, 4, 5. Alright, so 5 would be right here. That means this point right here would be our midpoint right here. Now, I erred a little bit, okay? I told you that it'd be 3.5 and 5. But that's not the exact midpoint. That's just how far into each of these this goes. We actually will follow the x value and the y value to find the exact point where they meet, and that would be at about 0.5 and 3. So this would actually be 0.5 and 3, or you could have written 1/2 and 3. Okay? So how did we find it? Well, we counted along the x portion of this line, and we counted along the y portion of this line, and found the middle of both of those, and it led us to this. Now, it says down here to identify a pattern and then write a general rule or formula for finding the midpoint. Well, I've already told you a general rule for finding the midpoint. What we could have done instead is we could have added the 2 endpoints of the x value, so -1 and 2. I could have added these two values. So I could have said, alright, 2 plus negative 1, that gets me 1, and divide that in half, that gets me 0.5, or 1/2. And that's exactly what I got over here. And I could have also done the same thing for the y value. I could have gone from negative 2 to positive 8. Let's see how that goes. Let's see. 8 plus negative 2. Now it's only coincidence that we're adding a positive and a negative number every time, but remember, these are different signs, so we're subtracting. And you divide it in half, that gets me 3. And that's exactly what we got. So what we're going to do is the formula, and this is how it's derived, you're going to add both the x values. Now these are two different x values, so I'm going to say x1 and x2, and I put them in that order because typically we've been doing them in that order, and it doesn't matter because addition, you can do it either way and it'll get the same thing. And we divide it in half. We call that find the average of those x values. Add them, divide them in half. Alright, and this is y1 divided by 2. So this is the formula we're going to use. Now, this next piece, we're going to complete this. We're going to use these two pieces, these 2 points, and our formula to figure out what the midpoint of this line segment is. So I'm going to take my x values, so x2 plus x1 divided in half, y2 plus y1 divided in half. Okay, we're going to add our x values, so negative 2 plus 4, negative 2 plus 4 divided in half, and our y values, 3 plus negative 7, 3 plus negative 7 divided in half, and we're going to simplify that. So negative 2 plus 4, that gets me positive 2 divided by 2, and 3 plus negative 7, that's negative 4 divided by 2, and that would give us 2 divided by 2 is 1, and negative 2 divided by 2 is negative 2. So then let's plot that point. So we're going to go over to 1 and down to negative 2. So let's see. So this would be the midpoint of this particular piece. And I'm finding out why it's not lining up with this graph is because these are two different problems. This is part A and this is part B. So if you're as confused as I was, that's why. So this is a whole different problem than this one. So this problem, we're going to do the same thing. If I find the coordinates of this, this is negative 3, 1. And if I find the coordinates of this one, which is positive 6, positive 6, and we'll just call them A and B for the sake of calling them names. Okay, so A and B, and we can use the same formula to do this. Okay, so again, we're going to substitute into our formula, add the x values, so negative 3 plus 6 divided by 2, and add our y values, 1 plus 6 divided by 2, and that should get us negative 3 plus 6 is 3 divided by 2, and 1 plus 6 is 7 divided by 2. Now this doesn't actually come out very nice, and they can't be simplified, so we're going to just leave it like this. Alright, so that's part of your guided notes. If you notice on the back, it tells you a couple other problems that you can use here. Okay. So, given midpoints at 1, negative 9, and 1 and at 6, negative 3, find the other endpoint. I'm going to leave that for you to do. Okay, but I will tell you that your answer would also be, here's what your answer would be. You get 7 halves, and you would get negative 6. Okay, but you need to do the procedure. Show the formula, plug in the formula, simplify, and try to see if you can get that answer. Okay, and if I'm wrong, come tell me and I'll fix it. I'll fix this video too. So let n be the midpoint of Lm. Lm has a length of 11. What is the length of Ln? Well, since n is the midpoint, it is halfway between Ln. So Lm. Ln would then be half of this length. So the length of it would be 6.5. If Nm, remember n is the midpoint, has a length of 11, what's the length of Lm? Well, Nm is half of this, because if you need a visual, it would look like this. Lm and n is our midpoint. Okay, so it just said that nm, this is 11. That means the length of the whole thing would have to be, this is 11 as well, so it would have to be 22. If ln has a length of 11, what's the length of nm? ln has a length of 11, what's the length of nm? Well, again, this is half of this, so that means this would also have to be 11, so the whole length is 22. Okay? Last but not least, talking about the distance. Again, this is a review of the distance formula. So suppose you have 2 points. Suppose you have 2 points here and here, and they want you to find out how far apart they are. The points look like graph A. Lines are drawn creating a right triangle, so you can, as shown in graph B. So these are the same picture, that's fine. So they draw the 2 points, they connect them with a right triangle. So remember, you can use 2 methods to find this length. You can use the Pythagorean theorem, alright, using how long one side of this triangle is, which is 3, and how long the other side is, which is 4, and plug it into your Pythagorean theorem, which is a squared plus b squared equals c squared. Or you could find using the distance formula. So knowing that these 2 points are negative 2, 1 and 1, 5, you could use the distance formula. And where you subtract your x values and square them, and subtract the y values and square them, and take the square root of that sum, or that sum. So either way you go, you would find the length. And at the bottom it says, what's the distance formula used for? It's for finding the length or distance between 2 points. Okay, and that concludes your notes. Fill in the rest. I want this to be complete, and that will be part of your grade. So good luck, and I'll film one more for systems of equations.